Okay, so let's look at number 28, which asks about a silver concentration cell, and it gives us the reaction where I have solid silver and I have silver ions, a 1 molar solution that is aqueous, and a certain reaction takes place within this silver concentration cell, and I end up with solid silver and still some silver ions. Only notice that the concentration of the silver ions are different. The question goes on to say, is there enough information to predict the standard EMF and the direction of the reaction from the given information? So the first thing I do is go back and I look at the equation again, and I think to myself, okay, is there enough information? Anytime I've given a molarity between two different solutions in a reaction, right here I'm given 1 molar and here I'm given 0.01 molar, then I know there's enough information to make, enough basic information anyway, to make some predictions. We call this a concentration cell because we are given the concentrations. Because the concentration is here, I would say that I have a greater concentration on the reactant side. And then I can obviously see that I have a lesser concentration on the product side of the equation. So that's really important information to start with. I know that in a cell like this, in a concentration cell, my reaction continues until equilibrium is reached. So I know that's what's going on in this cell. So I have to look at my molarities and I have to look for which one's the strongest. And immediately I say, okay, this 1 molar is definitely stronger than my 0.001 molar. Because it is stronger, that tells me the reaction, we'll say the reaction will proceed to the right. Reaction will proceed to the right. It's going to continue to proceed to the right until equilibrium is reached. If it's a concentration cell, and we know that the reaction is proceeding to the right. Why is it proceeding to the right? It's proceeding to the right because I have a greater concentration here than I have here. So I know it's moving to the right. And I can say, because it's a concentration cell with 2 different concentrations, that the reaction will continue, I'll say, until equilibrium is reached. I can also note that when equilibrium is reached, in any type of concentration cell, this isn't just true in this one, but in any type of concentration cell, when equilibrium is reached, then I can say that my E cell or my EMF or my electromotive force equals 0. So once I get to equilibrium, once this reaction has moved until equilibrium is reached and I have standard solution on both sides, the reaction will continue. When I finally reach equilibrium, I know that my cell potential is 0. It happens every time. It doesn't matter the reaction. What we have to pay attention to is that it's a concentration cell, and I know it's a concentration cell because it shows me the concentration, and I know that the reaction is continuing because I have different molarities. If the molarities were the same, then the reaction would be at equilibrium already, and it would be happening in a reverse and forward reaction at the same time. When it's happening at a forward and reverse reaction at the same time, then my cell EMF is automatically 0.